In our previous video, we took a look at the concept of a floating static route. A static route with an artificially high administrative distance that route only gets used if the other route that's primarily used goes away for some reason. So in this video, what we get to do is we get to implement a floating static route. I'll walk you through it step by step in the lab, and then better yet, we'll verify that that floating static route actually works. And here's our topology from our previous video. And what we're going to do is we're going to make sure that these interfaces, serial 3/1 on R1 and serial 3/3 on R3, we're going to verify that they're up. They have the configured IP addresses, and I'll also show you how to do the clock rate command in the event that you want to replicate this either on physical gear or packet tracer or GNS3 or viral, etc., etc., etc. So without further ado, let's go over to R1 and make sure this serial interface is configured to be up and has the IP address of 10.13.0.1 with a 24-bit mask. We're going to go ahead and open up PuTTY, and I'm going to open up sessions to R1, R2, and R3. Fantastic. I'm also going to go ahead and use the Enter key a few times just to clean up the screens. Looking good, and let's start our work here on R1. And before we start configuring on R1, let's do a show IP interface brief, see what we have. And currently, it's already configured. So I'll show you the steps to configure serial 3/1 in case you're doing this on your own. And it's basically 3 commands, and I'll walk through those right now. So on a router on this device, we'll go to configuration mode, go to interface serial 3/1. We'll issue the no shutdown command. We'll issue the IP address command, 10.13.0.1. the 24-bit mask. And then also the last thing I want to do here is do a clock rate, and let's set it, let's do a question mark, let's set it to 64,000, which is still significantly slower than our high-speed Ethernet network. So those are the 3 things we'd want to do on the interfaces. Bring them up, give them IP address, and do a clock rate. And you don't have to do clock rate on R1 and R3, just on one side of the link, and it'll be fine. So I'll type in end, and R1 is done. Let's go over to R3. On R3, we'll go into configuration mode. We'll go into interface serial. Looking at my notes, it's interface serial 3/3. We'll do a no shutdown. That would bring it up if it was already down. We'll give it an IP address of 10.13.0.3 with a 24-bit mask. Great, so let's go back to R1. And here on R1, let's do a show IP route. So currently, in fact, what we could do on that is we can tag on additional options after the show IP route. If we just wanted to focus on our static routes, we could do the command show IP route space, give it a question mark, and we could include the word static if we just want to see static routes. So I'll do that. It'll give us a little bit finer output there. And there's our 2 current static routes. So R1 knows how to get to the 10.23.0 network via R2. It also knows how to get to the 192.168.1 network also via R2. And if we did a traceroute is a fantastic tool on a Windows platform. It's spelled T-R-A-C-E-R-T. But traceroute can show you the hops in the path from the source to a destination. So if we wanted to take a look at the current path or verify it, we could use traceroute, put in the IP address of some destination. That's the server over there on the 192.168.1 network. Press enter, and it's going to show us the hops in the path. So the first hop was 10.12.0.2, which is R2. The next hop was 10.23.0.3, which is R3. And the final path was to the device itself on that network. And what this is showing us here is showing us that it actually sent 3 probes to each of those hops. And it's manipulating the time to live to get those responses back. So it took 16 seconds, 92 seconds, 32 seconds respectively for the 3 tries. But each of those 3 packets, as far as this first probe, went to 10.12.0.2 as the next hop. What we're going to discover is that once we add in a new static route and we have the same administrative distance as the existing static route, it's going to go ahead and start load balancing. So this value right here is representing the administrative distance for that route. So let's go ahead and add a new static route. Let's look at our topology. So for this new static route, we're going to say to R1, to get to the 192.168.1 network with a 24-bit mask, go ahead and use the next hop of 10.13.0.3, which is R3's serial interface that's reachable now by R1. And by default, it's going to use an administrative distance of 1. So we're going to have 2 parallel routes inside the routing table. So I'd like you to see that. That's why we're going to do it that way. And then once we see that, we'll correct the problem by coming back and modifying the administrative distance for the second route. So into configuration mode we go, and we'll add the route, IP route, to get to 192.168.1.0 with a 24-bit mask. The next hop is going to be R3's serial interface, which is 10.13.0.3, and I'm going to go ahead and use a space and a question mark, and this is where it's telling us we can add the distance. That distance is shortcut for administrative distance for this route. By default, it's going to give it a value of 1. I want you to see what that looks like, so I'll press enter, and let's do a do show IP route. Now, I'm adding the do in front of this right now because if I want to type in exit and go back to privilege mode, then type the show command, it works. But if I know the syntax, what I'm going to type in, I can be in configuration mode, I do the do command, and that saves me from having to exit out of configuration mode. So it's personal preference based on how you want to do it, but that's why the do is there. So we'll do a show IP route, and let me just add on static as well. That way I'll thin out the field for us. Look at this. This shows us our static route for 192.168.1, but check it out. We have two next hops. We have 10.13.0.3, which is over the serial link, and we have 10.12.0.2, which is over the Ethernet. So one of those is significantly faster than the other, and if we go out of configuration mode, if we do a trace route now to 192.168.1.200, check this out. It's sending 3 packets to determine each of the hops. And for this first one here, you'll notice that the first packet sent out, the first hop was R2, based on its IP address ending in the 2. And the second attempt for that same network, it went over R3, over the serial link. And then for the third one, it went back to R2, and it's going back and forth. And that's because of these 2 routes right here. So if we implemented a solution, we said, okay, we've got a backup path for Bob over the serial link, the manager would say, well, why is Bob complaining that his traffic is acting erratic and not as fast as it used to be? And the answer would be because we're load balancing to reach the 192.168.1 network. The solution to this is to artificially increase that second route over the serial interface, and by doing that, it's going to be a floating static route. And we can do that right now. Let's just go into configuration mode. I'm going to hit the up arrow key a few times, and there's our route. And what we could do is we could say no IP route and take the whole thing out, or because it's the same route, we could just go to the end of that and tack on, let's do a 55 for administrative distance of 55, which is worse than 1. Press enter, and now check this out. If we do a do show IP route and press enter, now we have a single route, and that single route is through 10.12.0.2. Well, what happened to our floating static route? This guy right here. Well, he's sitting in the config. The router knows that that's an option. So if this next hop of 10.12.0.2, or if this interface that router 1's using to get to that router, if that goes down and that path is no longer available, the floating static route will kick in. So if we look at our topology once again, here's what I propose we do. Let's play a mean trick on R1, and let's just shut down gigabit 1/0. If we shut that down, the next hop of R2 at 10.12.0.2 for that route, that will no longer be available, and that will cause the floating static route that we just added with a administrative distance of 55 to be the best option available, and that route will kick in on R1. So let's do it. Let's go to interface gig 1/0 here on R1. We'll do a shutdown command, press enter, give that a moment, and then let's do a do show IP route. And we'll add static just for grins. Check this out. Here is our static route now. It's the 192.168.1 network with an administrative distance of 55, and the next hop is 10.13.0.3. So let's verify we can ping a device on that 192.168 network. So if we do a ping to 192.168.1.200, survey says, the curse of the first ping. So let's go ahead and do it again. So the second time is totally successful. And then let's also do a trace. The trace route out to 192.168.1.200. And that shows us our current path. So the first hop is 10.13.0.3, which implies that we're using that path. Also, if we bring that interface back up, gig 1/0, let's do it. And we do a no shutdown and give that just a moment to think about life. Once that interface comes back, the route with the administrative distance of 1, because it's better, is going to go into the routing table And the other route with the administrative distance of 55 is now floating, hence the floating static route waiting to jump in. So we'll do a show IP route, and there's our original route through the Ethernet interface once again. So in this video, we've actually implemented a floating static route, and we did a fairly simple topology. I would encourage you strongly to practice and do what we did here together in the lab. Do that hands-on practice to help see the results yourself. Do it a few times to get comfortable with it. And I also would be remiss if I didn't point out that when we take out a whole interface like I did on R1, we lost more than just that one route to 192.168.1. We lost routes to the 10.23 network and other places. So we'd also want to consider that if we lose an interface and we're setting up routing, we want to make sure all of our bases are covered. We can do that by testing, test from here to there, verify all the routes are present. But you know what? Another option that's very, very handy in production networks is dynamic routing, where the network can change and the routers can talk to themselves using a routing protocol to dynamically update the routing tables. And we'll cover dynamic routing in a separate skill. So I wanted to point out that we need to take a holistic approach to making sure packets can get from point A to point Z and from point Z back to point A, because that's how network communications need to work if they're going to be effective. So thanks for joining me in this hands-on lab for floating static routes, and I'll see you, my friend, in the very next video. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.